Hi, we are going to be learning about one-dimensional kinematics, so how stuff moves. In particular, this lesson is going to focus on position and distance, displacement, average speed, and average velocity. And we'll go through some examples as well. So let's start with position. I've got a number line here which shows position. So it's like those ones that used to get in elementary school where you have one down here, and you've got 2 and then 3 and then 4 and so on as it goes across. And I was so excited to find a little gator one. Usually when we're talking about position, we're talking about in a particular direction. X would be horizontal and Y would be vertical. We don't usually deal with the Z direction in physics. So let's just talk position. Position is where you are. So if I am here, then my position, X, is equal to 5. And if I'm here, my position is X is equal to 9. And so that's position. That just is telling you where you are. So now let's take a look at distance. In physics, regular physics, we didn't really distinguish between distance and position. We kind of use them interchangeably. But in AP Physics, when I talk about distance, I'm really talking about total distance. So how far did you go? The odometer reading, if you will, of your trip. So let's say that I start at this spot right here. That means my position at time equals 0 is equal to 5. Now that little 0, that position at time 0, that little 0 just means it's the first one. That's my first position. Many times you can make that be 0, and it makes problems easier to solve. I call this x0. Most physicists will call it x0 because it sounds more official. So if you've been following COVID and R0 values, that little 0 is a naught. I like calling it 0. So I'm going to call it x0, but you can call it x0 if you would like. So that's our starting position. Let's say that then I go to x is equal to 9. And then let's say that I go to x is equal to 2. So those are all my positions at different times. So let's look at distance. If I start at x equals 5 and I go 1, 2, 3, 4 places to x equals 9, my distance is 4. I've traveled a distance of 4 little boxes. But if I also then go all the way back down to x equals 2, I've gone 4 boxes plus another 1, 2, 3, 4, 5, 6, 7. So I've gone a total of 11 boxes. So my distance is 11. So it's just like if you go in your car and you go north on Wadsworth for a while, and then you go south on Wadsworth for a while, your car odometer doesn't care that you change direction. It just keeps adding distance onto your car. So the odometer reading, the total distance, is going to be the total distance that's covered. So now let's talk about displacement. Let's look at those same positions that we had before. So our x of, actually, let's erase that. So let's say this one is our starting position. And then let's say here is our ending position. So this is x0, and this is our x, so where we're ending up. One thing that I haven't really talked about yet is direction, whether it's positive or negative. In this case, our number line is headed towards the right. So positive is towards the right. It's usually a good idea in kinematics problems, actually a lot of problems, to define a direction as positive. You're the ruler of your own physics universe. So in most problems, you get to decide which way is positive, and you just pick the way that makes most sense to you, or with the data that you're looking at. I'm going to make positive to the right because it's increasing as we go to the right, more and more positive. So if I start at 5 and I end at 9, then my displacement is my ending position minus my starting position. So my x minus my x0. Back in regular physics, we probably would have called this d final and d initial. So the final minus the initial position. So this would be 9 minus 5, or a positive 4 displacement. So I started here and I went 4 places in the positive direction in order to get to the 9. All right, so now let's say that I start at 9 and I go to 2. So let's say, let's erase, or let's keep the x0 where it is. Let's say I start at 5 and I end at 2. So my final position is 2, my initial position is 5, and if I take 2 minus 5, I get a negative 3. That means from the start to the end, I'm going 3 in the negative direction. So that's my displacement. Now let's say that I do an intermediate step over here. So I start at 5, I go to 9, and then I end up at 2. My displacement only depends on where I started and where I end. This 9 has nothing to do with it. This is my ending position. This is my starting position. It's still going to be a negative 3 displacement. Now let's say I go back to 5 again. So I started at 5, I go to 9, I go to 2, and now I'm back at 5. My total displacement is 0. You got it. So track athletes out there, if you run the 400 or you run the 800 or the 1600, your displacement for the whole race, 0, because you finish where you start. So now let's talk about average speed and average velocity. Average speed is the rate at which distance is covered. So speed means that it doesn't depend on direction. It's just the speed that your car is traveling at any given moment. That's a speed. It doesn't matter whether you're going north, south, east, or west. So average speed is going to be the total distance divided by the time that it took you to get there. So the change in time from when you started to when you ended. So total distance over total time. Same thing that we talked about in regular physics. Average velocity, on the other hand, is different. Average velocity is the displacement over the time. So it's the change in position divided by the change in time. So the direction is going to depend on which way you made positive. So track athletes, sorry to single you out, but if you run the 400, the 800, the 1600, if you're going around that track and come back to where you start, your displacement is 0, which sadly means your velocity, your average velocity is 0. Now your average speed is not, because you're covering distance while you do that. You're just not having any displacement while you have that.